Hei og velkommen alle sammen. Dette Noracoms webinar rundt temaet Motorola MOTOTRBO DMR Teknologi. I dag vil vi gå igjennom en liten presentasjon hvor vi går igjennom teknologien og mulighetene vi har i MOTOTRBO. Litt informasjon rundt dagens webinar. Mikrofonen til alle deltakere deaktiverte. Under sesjonen så kan du stille spørsmål i feltet for spørsmål og svar. Dagens webinar vil bli holdt på engelsk, men still gjerne spørsmål på norsk. Dersom du har utfordringer med kvaliteten på webinaret, så kan dette endres via innstillinger. Det samme gjelder også hvis du skulle ha problemer med lydkvalitet, så se til at du har valgt riktig lydenhet. Gjør også oppmerksomhet på at det blir gjort opptak av webinaret for egen evaluering og for å senere kunne legge det ut i andre sosiale kanaler. Webinaret har også en liten forsinkelse på ca. 20 sekunder. Så vær obs på det. Hvem Noracom? Noracom etablert i 1998. Vi et heleid norsk selskap. Vi Motorola Platinum-partner og en løsningsorientert leverandør. Vi har en egen stor teknisk avdeling. Vi selvfinansierende, og vi driver en sunn forretningsdrift, og i dag 10 ansatte. Dagens gjestepresentør Jonny Bundgaard fra vår samarbeidspartner Danimex. Over til deg, Jonny.
Ja, tak skal du have. Mit navn Jonny Bundgaard, som det nævnt, og jeg ansat ved Danimex, og det har jeg været i 23 år, så efterhånden så kender jeg lidt til Motorolas produkter. Jeg vil afholde præsentationen på engelsk, fordi slide-dækket på engelsk, og så tror jeg det nemmest, også fordi hvis I har nogle tekniske betegnelser på norsk, som jeg ikke kender, så tror jeg det nemmest på engelsk. Så vi går til i gang med præsentationen. Danimex been around for more than 30 years, so just as Noracom, we not just the deliver and run away company. We are specializing in two-way radio solutions with a lot of different technologies. We are going to talk today about DMR standards and MOTOTRBO DMR, and that will be a brief introduction to everything on this one. The DMR standard is an ETSI standard, and every radio manufacturer who signs up with the ETSI standard is obliged to make radio systems and radio components that abide by the standard, and subsequently that in many cases the devices are interoperable to a certain degree. So MOTOTRBO, we support a lot of different things for voice data, GNSS, that is also GPS tracking, telemetry and certain apps. And it's built upon the ETSI standard. However, there are some variations on the standard. So let's go and have a look at it. MOTOTRBO is the DMR ETSI standard. It's based on TDMA protocol. Because everything is digitized, we have extended audible range, so that means that the voice should be better over a longer distance. We all know from the analog world that when you move towards a distance from the central for the transmission point, then the voice starts degrading with noise, etc. The digital has much clearer voice for a longer distance. However, if you are close to your analog transmission station, I believe that analog is a better quality overall. Anyway, by introducing digital TDMA protocol, we have doubled the capacity on the same RF channel. So because we have doubled the capacity and we're using TDMA time slot assignments, then we can also have better talk time because the radio is not transmitting for the full duration of the transmission of the talk time. And MOTOTRBO has been around for 13 years, and the technologies has evolved immensely throughout those years, and we are actually has got a full suitable package for this. And you can have a lot of applications to work together with MOTOTRBO. So the idea is that if you have an analog system, you can start replacing the components, and you can go to digital radios, so you can exchange them. The radios are, except for one exception, all analog compatible. Most of them also do SELECTIVE. If you're using SELECTIVE 5-tone in your environment, they can do that as well. And in the digital protocol, they have the 2 time slots operational. MOTOTRBO and all DMR relevant products, they support private call, which means, or individual call. So you can address a call to an individual radio on your network. That call is private between these 2 entities. This means that nobody else can listen to the call, except if you are a dispatcher, because then you also can listen to the call, but that's besides the point. Then we also have group calls, which means we can make one-to-many call types, which indicates that if you are in the same talk group, then everybody in the talk group would hear the call, but the people who are not a part of the talk group will not hear the call. Again, group call is private within the group. We also have the capability of providing all call. An all call is a broadcast call. It's a one-way call. For example, you can notify we have a fire, do not go near the incident place, or something like this. And that will be told to everybody on the channel or on the network, irrespectively of which talk group they belong to. Sorry. On top of that, we also have the possibility to do a lot of different facilities to the radio, from radio to radio. We can enable and disable devices. We can provide a remote monitor radio check. We can have GPS tracking. We can have text messaging and job ticketing. We can also have different levels of encryption. The only thing is that the 256-bit AES encryption requires export license from the manufacturer and the government. There's also a possibility to migrate telephony into your radio network, either via 2-wire telephone pads directly to the back of the repeater infrastructure, or using a SIP client using a third-party software. I have a little live demo that I would like to run now. So now you can see my 2 radios, and you will see that I have 2 radios in front of me. They're operating on an IP Site Connect system. 4003 and 4002 are here. In case I want to say contact, and then I can scroll down to my contact 4002. That was 4002. And then I can go into, and then I have an opportunity to select what I want to do this one. I can view the details, I can edit, I can send a radio check to the device. Radio check is like a computer ping. And when I press this one, I got a tick, the radio is online. If the radio was not online, I would get failed. I have the opportunity to say, disable the radio, and if you note the radio to the right, damn, it shut off. So the radio is dead. You can see there's nothing in the radio. However, same radio, don't worry. My battery didn't come off. So take the battery off, reinsert the battery, and you can see the radio comes on. And I'll keep this radio screen alive while it's booting. Oops, it went dead again. There's nothing. So when I press enable now, I'm telling the radio to be switched back on and come back online. So all this can be done even in a simplex environment, even if the radio has nothing else infrastructure-wise to be done. And now the radio is back on traffic and we can start talking. As you can see, we also got a PTT ID. You can see which talk group is calling. We can see the identity of the calling party. So everything is programmed in the right way. And 4002 talking back. So that was a group call. We can also do remote monitor. Remote monitor is eavesdropping. So you can actually listen what is happening in a car or in a room if you so desire. Of course, this is something that we have to do with care. One of the big advantages is the over-the-air reprogramming, or the OTAP. Motorola MOTOTRBO has a very comprehensive package about doing OTAP. You're deploying a network, then you have to deploy radio networks, 300 users. You put up a new site or you are getting a new frequency. You have to pull all the radios in and reprogram them. That's no longer necessary. If you prepare your programming on the fly or before you start and give it an OTAP key, it's possible for you to reprogram all the radios over the air. You do not even have to pull the radios back in. It's a quite comprehensive package that you get just from having the radio. We're going to look a little about the systems that we have. We are not going to address the subscriber radios. I believe everybody has a chance to see what radios are available. But you have the systems. You have conventional on the far left. You have IP Site Connect, Capacity Plus, and Capacity Max. These are the step up of technologies that the system supports. We have a vast variety of radios. Then we have the accessory packages and the applications. The applications, there's a strong suite of applications that can be associated with the MOTOTRBO packages from different vendors. There are dispatch solutions such as Smart PTT TurboNet, and there's a lot of telephone interconnect and alarm managing systems. There's a vast array of systems that you can attach to your radio system, including telephony. One of the technology issues is that we said earlier we have 2 time slots, which means that we can have 2 simultaneous calls per carrier. This used to be only available when we had a repeater because we needed some sort of synchronization between on the TDMA protocol. But Motorola released something called dual capacity direct mode. It's also known as 6.25 kilohertz equivalent. This means that you can also have on the same frequency, you can have 2 simultaneous calls, which means that you are actually utilizing the full spectrum of your allowance, the 12.5 kilohertz. So you can have 2 simultaneous calls. One of the things that it was a limitation before this was released was that you had to have some timing. Each radio can be programmed to be a timing leader. It can be eligible or forced or not at all. And by having a timing leader, what happens is that every 4.5 minutes, if nothing is happening on the frequency, one is coming up and saying, hey, I'm the timing leader, this is the new timing. And the remaining radios are being automatically synchronizing up to this. So we have the opportunity of having the timing leader. On top of the DCDM, there's also an extended range direct mode. We can have a client who may not have a very good, cannot get more frequencies. Then it's possible to use the same frequency and utilize the 2 slots on the repeater to extend the coverage. And that is actually working quite well. So you can have extended range direct mode on a simplex frequency. It's just rebroadcasting on the other slots. Before I can continue, do we have any questions for what I have covered so far? Yannick?
No, not yet. So we're good to continue.
Thank you. Now we're going to talk about the systems. We are starting off with the conventional radio systems. Let's go and have a look. In an analog repeater, you have one frequency pair, you have a channel, and that gives you one talk path. By utilizing TDMA, we can have on a digital repeater, it's the same device, it's just programmed with another channel. Then you can have one same frequency pair, but in this case, we now have two channels as in two simultaneous talk paths. We take these repeaters and we say that we have 6 repeaters to cover a city. They are now standalone, so that means that it's LAC, LAC, local area channel. And we have 6 individual sites and 6 individual talk paths on time slot 1 and 6 on time slot 2. However, if we join these together using IP, imagine that we are using IP to link these together, then we are suddenly making them wide area channels, WAC. So time slot 1 is rebroadcast on time slot 1 throughout the network. All 6 repeaters are being active or going live if somebody activates time slot 1 anywhere. Then all time slots 1 will be active. Same thing applies with time slot 2. You can actually do it with time slot 1 being wide area channel and time slot 2 being local area channel. So the user has the opportunity to have local traffic on time slot 2 and wide area channel is being broadcast throughout the city. These are drawn as a pearls on a string, but of course they can be in a star shape, they can be in any other way shape. The only reason why I've drawn them like this is easier to make straight lines. So it's just to recap, everything set on time slot 2. On time slot 2 here is automatically rebroadcast locally and rebroadcast on time slot 2 on the other side, and vice versa. Time slot 1, everything set on time slot 1 is rebroadcast. And now it's up to the programming of the radios whether people listen to this call or not. If they're in the same talk group on time slot 1, they will all hear the call. However, the time slot is busy, it's occupied if you are not in that talk group. That is IP site connect in effect. I have a little drawing here where you can imagine that you have 2 sites linked using IP. You have some subscribers, and if one of the subscribers is moving to the other location, then it will automatically roam across to the new location. So I need to ask Yannick, do we have any questions so far on this topic?
We do not, but I would encourage anyone who's joining us on this webinar to ask any questions if there are any. So feel free to continue.
So what we have done is we looked at conventional single site and conventional IP site connect. Now we are shifting to capacity plus. Capacity plus, we are making a new technology taking place. We need to install a license on the repeater. The license is called capacity plus single site. We can also increase that license to have in cross capacity plus multi-site, but we'll come back to that in a moment. So every radio that is not currently in a call are listening to the appointed rest channel. The infrastructure is appointing a rest channel amongst the repeaters. So the rest channel is where people are resting. If somebody engages in a call, then the new rest channel will be appointed. The repeaters amongst themselves decide which one is the next rest channel. And the current or the old rest channel becomes the traffic channel. It's a very fast handover. It also means that every time there's a new call happening, a new rest channel is appointed. So there's a lot of IP traffic happening on the infrastructure backbone. In capacity plus, it's also possible to have another scenario. Something is happening. Oh, now it's coming. In capacity plus, we have three of our 4 slots occupied. The last one is the rest channel. And in case if somebody engages in a call, that channel will also be utilized for communication. The remaining radios appear to be without coverage, but they're not. If they have the right, or you press the emergency button, then they will knock off a call of the existing system and take over the channel. So we can still have some transmit interrupt functionality on the network. Link Capacity Plus. It used to be called Link Capacity Plus. Now it's called Capacity Plus Multi-Site. So Link Capacity Plus is where we have different sites. They have a rest channel on each side, and they have a switch to handle the communication within the site. Then we need to connect these sites using a router. There's a quite strong demand for the quality of the router and the brand name and which standards the router can handle. And we have had people in the past trying to do it with VLANs because that's what the IT people like to do. But unfortunately, VLAN doesn't support this. You need the router in play. VLANs on their own cannot support this functionality. So if we imagine that the repeater on the left side, the rest channel, somebody wants to engage in a call. Locally, a new rest channel is appointed. The repeater will communicate to the rest channel repeaters on the other locations. They will each location will appoint a new rest channel and give a go ahead back and say, yes, we are ready to process the call. And all the radios that are needed if it's the talk group 1 will automatically be appointed this channel, and the communication can process. We can also imagine that the call was actually a private call between two of the radios. That means that once the two radios and the call is established, the remaining site will become idle and calls will not be happening on that site. It will only process that. Or if we can also say that on a static programming, we can say site 1, site 2, site 3 will handle talk group 1 calls, all of them. But site 1 and site 3 will handle talk group 2, which means that then it would also not even light up site 2 in order to establish the call, because that is not a part of that talk group. And this is done by a listing in the software. I just have a sample of it here. That took us through Capacity Plus and Link Capacity Plus. Do we have any questions so far?
None yet.
None yet.
We can continue.
We can continue.
Yes.
MOTOTRBO also supports voting. And with voting, it is a why or at all consider voting? Remember, the repeater has a transmit power of maybe 25. I do not know the Norwegian rules, but in Denmark it's 25. But you can also have 50 watts on the repeater. You can have up to 100 watts if you so desire, if you get permission to use on 100 watts. But the portable only has between 4 and 5, 4 for UHF, 5 for VHF. This means that even though that our footprint for the transmit of the repeater, the downlink, is quite comprehensive, then the portable will only actually work when they're close to that site. By introducing a receiving repeater into the scenario, it's possible to increase the coverage foot map. You could also, people would say, why don't you just put up an extra IP site connect? But then you have a lot of surplus energy that you cannot use for anything. So I have this little drawing where you can see the center is receiving and transmitting, whereas the base radios around the center are only receiving. They're the extended ears, which gives a better footprint. Can also be done in IP site connect. If you have an IP site connect system and you have some coverage, you know that your transmission reaches the point, but the portable cannot respond back. Then it's possible to do that on IP site connect, and it's just having to have the man to match the frequencies. Can also be done on capacity plus. And I have a little scenario here. If you imagine that you have a scenario where you have 4 repeaters, these repeaters will have to have a capacity plus license. That costs a little money. Then we have the receiver multicoupler, the combiner. We require 4 pairs of frequencies. And in this case, we've chosen 2 antenna operation. But we have a footprint that is not really covered. You can see this striped area. There people cannot receive. Actually, we can receive the infrastructure, but we cannot respond. The infrastructure cannot hear us. So we have 2 options. Option 1 is to set up a similar site out there in order to cover the environment. So we have a combiner, we have linked capacity plus licenses. They are more expensive than single site capacity plus licenses. We have a lot of things that we need to do. So we have to have, that's an additional cost associated with this, quite a comprehensive cost. The combiner is quite expensive as well. That is one way of doing this. We suddenly require 8 pairs of frequencies, and we need the linked license. However, if we choose to put up a voting site there, we do not need capacity plus linked. We do not need the transmission combiner. We do not need the extra frequencies because we are reusing the frequencies from the main site. So all we need to add is a little voting license. If these sites were running on solar panels, we do not need to provide enough power to run the transmission part of the second site. We can just have a smaller solar package. So there's a lot of advantages by utilizing voting. And of course, voting also supports link capacity plus. If you have 2 repeaters on a site, the voting satellite receiver locations has to have 2 there as well. So the numbers has to match. That gives me the opportunity to ask if there are any questions again.
None so far.
Thank you. And then we are going to look at capacity max. Capacity max is the one you would choose if you want to have a control channel and the what do you call that? And the advantages that comes with having a control channel. The rest channel doesn't transmit all the time, but the control channel does. And that means that there's a full priority scheme and a lot of other things that works on capacity max. Capacity max is the DMR trunking solution. People ask me, but why not? No, I'll take that later. So this is working DMR tier 3. DMR tier 3, if you have a DMR tier 3 compliant product, it will also work on capacity max if capacity max is purchased to be able to cater for non-Motorola protocol. So it is DMR tier 3 and it is interoperable with other vendors. This one I like because it's sort of a little comparison between the 3 different main technologies that we're talking about. On the left, you see IP Site Connect. In the middle, you can see Link Capacity Plus, the capacity, and to the right, you see the capacity max. So how many users per site? My problem is that Motorola and a lot of others are using slots, and one slot is 100 users. However, it really depends on how many talk groups you want, how many simultaneous calls you want, what is the capacity of the amount of users. But on sites, you can have 15 sites on Link Capacity Plus, you can have 15 sites of IP Site Connect, but you're going to have 250 sites on Capacity Max. How many slots can you support on each of the technologies? IP Site Connect, you can support 2. And Link Capacity Plus and Capacity Plus, you can support 16 time slots, as in 8 repeaters, plus maximum of 20 revert for data for GPS. Whereas on Capacity Max, you can have 29 voice talk paths on a single site, plus 12 GPS revert sites. So you can have pretty advanced systems. You can have 30 time slots on 250 sites. Remember, one of the time slots is being used for control channel. It's full trunking. It's got a centralized controller. You can have redundancy on the controller, and you have a dedicated control channel. By that, you have a full subscriber access control, which you do not have on the lower tier environments. So you have full access control subscriber. So you can select or choose to have full authentication of the devices. Transmit interrupt is built into the most of it. Remote monitor, the queuing, enabler, and disabling are available. You can scale it up. You have a centralized the CMSS system. That is the centralized controller. You can have that backed up. It can be on the same location, or it can be co-located, so it can be located somewhere else. All you need is good IP between them. There's fallback facilities, so if you have any problems, if you need to increase by the number of sites, it's just adding another site and telling the infrastructure that the site is there. There's a lot of text on this slide deck, but the left side is the core features that are defined and included in the interoperability procedures. Motorola, as well as the other manufacturers, are making interoperability tests. And so the things are ETSI standard, and then the test, does it really work as we described? The second column, the additional features, they're defined and they're not yet tested with interoperability testing. But on the MOTOTRBO side, you have additional features. We have emergency call with voice to follow. That works all the way, not only in Capacity Max, that works all the way down, such as over-the-air programming, the voice announcements that the radio supports. Many of these are inside of the radio. The Impress order, the Impress energy, you can check what batteries are on the radio and how well they're kept, etc., etc. There's a lot of very, very advanced MOTOTRBO technologies already built into the device that can be utilized in Capacity Max as well. The infrastructure features, then you have some more value added where you can have more facilities, and the system features enhanced channel access onto the authentication. These are the things that you do not get if you are working on standards with interoperable with other products. What is supported by Capacity Max? The whole 4000 series of radios, and also the repeaters on the SLR 1000, 5000, and 8000. 10 watts tower mounted is the SLR 1000. 50 watts rack mounted, the SLR 5500, and the SLR 8000 that can do up to 100 watts. People ask me why we have Tetra. Why should I go DMR? The thing is, Tetra can do Tetra. That's what they're good at, and they have a very, very comprehensive protocol, and a lot of manufacturers are actually supporting that protocol. But when you're talking DMR, you can work all the way on the same device. You can work all the way down from simplex analog via analog and via repeater analog, all the way up to IP side connect digital, and to link Capacity Plus and up to Capacity Max on the same device. All you need is fancy programming and maybe some licensing. You can even install an option board and have MPT 1327 operating on these devices as well. So you have the full range of communication. So your communication requirement doesn't require replacement of terminal every time you want to do one step up. You just add a facility to the radio, either by programming or by licensing. This is going to be my last slide. I hope you're okay with this. So let's just recap. What do we get? We get MOTOTRBO, that's the on-site, as in you can have one repeater where you can have voice and data and a certain privacy, and a few applications that you can extend to a local, to a regional area, and then you call it IP Site Connect. So you can have greater coverage, but still only 2 time slots, as in 2 simultaneous calls. Then we can shift to Capacity Plus, and the Capacity Plus can increase our single site coverage up to 16 repeaters. Oh, sorry, 16 time slots, 8 repeaters. So you can have 16 simultaneous calls on the same site, plus the data calls. You can have Link Capacity Plus, which means then you are increasing up to 15 locations and working on Link Capacity Plus environment. So you have the same density, you can have the same amount of subscribers on this environment. It's really clearly stated here that Link Capacity Plus and Capacity Plus, that is not designed to be a countrywide network. It should never be. It is actually a regional environment. If you need to, you can actually make up multiple Link Capacity Plus systems. For example, if you have the police force example that you want to have in one commune, and then you can have another commune with another radio system, and then you can patch on demand by the means of control room solutions, etc. If you want to do a countrywide system where everybody can hear everything, then it's Capacity Max. That is tier 3. So that took it to my slide deck. Over and back to you, Jannik.
Thank you very much, Johnny. Da vi ved veis ende. Det har så langt ikke kommet noen spørsmål inn. Men vi selvfølgelig så oppfordrer vi jo dere der som sitter og ser på nå til å stille en spørsmål. Det nå en delay på cirka 20 sekunder, så vi venter litt grann til I tilfelle så kommer noen spørsmål. Dersom du skulle ha noen spørsmål etter webinaret, så må du gjerne sende de direkte til din kontakt I Noracom dersom vi har I kundeforhold. Alternativt så må dere sende av gårde det dere måtte lure på til webinar@noracom.no. Vi vil også minne på at den 2. oktober så vil neste webinar være. Tematikken for den 2. oktober det Wave, eller det vi kaller radiosamband over LTE og 4G, bredbånd generelt. Det ser ikke ut som at vi får inn noen spørsmål. Men som sagt, igjen, den 2. oktober så ses vi igjen, og tusen hjertelig takk for at du fulgte med. Takk for nå.